explained by a special theory of relativity. So to generalize that, he gave us general relativity, right? Literally, it's general relativity versus special case of relativity. So now gravitation is allowed. Now gravitation has to be explained, because remember, gravitation makes us accelerate, right? So what is gravitation? That is explained by general relativity by Einstein in the 3 spatial dimensions and the 1 time dimension. And he had already told us that space and time are relative. And now in general relativity, he's basically saying that the bending of space-time is gravitation. Gravitation is not regarded as a force necessarily in general relativity. It is the curvature of space-time. So more massive an object, it's going to curve the space-time around it the even more. And in fact, he also predicted gravitational waves from like big explosive gravitational events like cataclysmic explosions, supernovae, black hole mergers, neutron star mergers, and we have even started to measure gravitational waves now, much later, once now we have the technology to measure gravitational waves, almost I think it was over 100 years after Einstein first predicted them. So general relativity, once again, has a lot of experimental success. A lot of the predictions of general relativity have come true, been shown observationally. But ultimately, it was very much a theory that was trying to explain the physics, and his heart was all about trying to explain the nature and the physics. It wasn't so much about making everything a math problem, right? That's not really Einstein. He was very much more grounded in the sort of physics things. So he didn't do this. He did general relativity, and the mathematics allowed for more dimensions, but he kept it as a 3D space and 1D time type of theory. It was Kaluza who modestly added 1 dimension. Modest in the sense that at least he didn't add many more dimensions, but he did add 1. So it was a leap already to go from 3 spatial dimensions to just adding the 1 spatial dimension. But you can see how if you say that adding 1 spatial dimension is okay or allowed, then why not add a few more? I think currently we have the 9 spatial dimensions in string theory, and that's how they are going to make this math work and give us properties that are seen in quantum mechanics, because remember, string theory is about unifying general relativity with quantum mechanics. Okay, so Einstein did not, however, formulate it in the way of extra dimensions. Einstein formulated general relativity in the familiar setting of a universe with 3 spatial dimensions and 1 time dimension, like a good boy that we know and love, because we understand 3 space dimensions and 1 time dimension. That is nothing new there. But even with that, GR is a little hard, as somebody noted, because GR is still in the 4 space-time, where it's like the 3 space and the 1 time dimension are sort of on an equal footing in the mathematics, right? So it's still not easy mathematics when you do general relativity. It's a little bit different. You have to kind of change your realm of mathematics to do the math a little differently. You have to define things like the metric, the geodesic, all of that. Which, by the way, we talk about in a different live quite a while ago. Okay? The mathematical formalism of his theory, however, could be extended fairly directly to write down analogous equations for a universe with additional space dimensions. So this is where he wrote down general relativity for the 3 space and the 1 time dimension, but it can actually be extended to include more spatial dimensions pretty easily. And by easy, I mean it's not really that easy. It's not like 1, 2, 3, 2 plus 2 math, but it's allowed, it's allowable. Okay? So under the modest assumption of 1 extra space dimension, Kaluza carried out the mathematical analysis and explicitly derived the new equations. So Kaluza, as a good student of general relativity, which by the way most, if not all, string theorists are, they start with general relativity and then they extend it. That's really what's going on. He found that in the revised formulation, the equations pertaining to the 3 ordinary dimensions were essentially identical to Einstein's. This is another thing. Once you extend general relativity to have, say, another extra dimension,